Yes, let's have a look at this start, you could say, of assignment 2, because there are some small things here that I would like to point out for the future as well. How do we sort of work in this environment here? And first of all, I always have two windows open into Orion. The terminal window here, I'm using this MOBA Xterm for that, and the RStudio here. And this is how you should work, right? With these two windows open, so you can go back and forth between them, because you need them both. You need them both. And here I have started now to sort of, or actually this is just a continuation of the R Markdown document I made in a previous small video, right? I have taken away a little bit from the start here, and I have focused on this part 3 of the assignment 2. So let us also click open the document, the assignment 2 document here. So you can see part 3 is about the pre-processing with FastP. And here it says what we should do in this part 3. And then I make a similar section in my Markdown document. And I saw that many of you did not do this in the first assignment. Please do this. Make a header, and remember there must be a space here. Otherwise it will not become a header line. You should see that in the HTML file that you produce. Verify that you actually got these titles on each section. Otherwise it's horrible to read these reports. Yeah, and then you need to add some text explaining what you're trying to do. And this is important, or this becomes more important now. We will be more stricter on this now in the second assignment, that you can actually write some text explaining what you're, not only the code. Not only the code. You need to write some text explaining what you're doing. And here I just, and this I did in the previous video, I just pasted in some code here from a shell script just to show you that you can use this bash chunks and set eval equal false to avoid evaluating these, because otherwise we don't want to run this Unix code when we are knitting the document. We are just showing it here, because actually the code is in a separate file here, right? And this is not now just a copy of of that very first shell script that we made in this course. Because that was also about running FastP with the proper partition specification here. And we specify how many threads we want, and that's the same as here, right? And the amount of memory is 10 gigabytes. It's usually enough for this small job here. This is a very small job. That's where we start in this end, you could say, of the Spectre. And then there are some specification of input here, the files we want to process, and the resulting files that we want to as output, you could say. And here is the command line then for running FastP, at least how it was done in that exercise, or in that module 5, I think, document. Yeah. So that's actually a big point. When you're starting out making this shell script, look up the module documents. Where did we do something similar, right? And then you have to understand a little bit what is going on in the module documents, so you know which sort of shell code template there you should copy. Because I would strongly recommend that you always do it like this. You copy from the module document something, paste it in here, and start changing it. This should always be the way you work. And I think this will also apply for the future, right? Even after bin 310, you will now have a lot of shell scripts available that you made now in bin 310. And if you come to your sort of master thesis or whatever, you always, and then you can take away these 3 lines. Soon as you are out of bin 310, you should take away these 3 lines, but the rest could be used or modified, right? And this is how I do it myself, always. I never start typing a script from scratch, like from nothing. I always copy some old script and change it. So I think this is a good way of working. Okay, so here we then have this fastp script, and here we have the RMD, the markdown file. And actually, if we go to the assignment here, it said that we should use fastp on the Illumina data only. Yeah, that's the first thing. So we have to go into the shell script here now, and now I go into the shell script here. Because the input files specified here are not the correct ones, right? These were some we used in module 5. This is not my assignment2 data set. Where are my assignment2 data? They are in another folder, right? Yeah, it says up here somewhere. Where did it say where the data was? It's in this courses folder. Yeah, here it is. Here it is. This folder. So let me copy that. And then I go to my terminal window. Terminal window. And I look into that folder. And now I just right click here to paste in the text I copied from that document. So this is the path, right, to this folder here. And if you wonder about this command here, it's not a native Unix command, but if you look into the end of module 5, you see how I made myself an alias. This is actually a short for LSA minus, sorry. This is actually a short for this. This is a proper Unix command. ls with 3 options. And it will list the content in a long format, and then it will also list all content in long format, even hidden files and stuff. So if I repeat it, I used up arrow to repeat old commands. I can change it. I have made an alias for this, so I called it just LSA to list the content. And here you can see all the data files for all students. So my student number is now 100. 100. If I go back to the module document, we can see that the sample files should look like this, right? The Illumina data, where X is the student number. And then I notice, okay, if my number is 100, there should be some underscore 100 underscore in the file names, right? A and B. And then I can go and look for these files here by listing all the content, and then I pipe it into grep, which is a command for searching for specific text or regular expressions. So if I search for this text among all the file names here now, all the text which is listed here, I only get listed my files. Can you see that? I list I list all files, but then I said pipe this output into grep and this text, and then it will only sort of filter the output, so it only shows those lines that contains this particular text that but I need to know what to look for, right? But this is something we do very often on the terminal. If you have a lot of files or whatever, are my particular files in there somewhere? Then you can do it like this. And they are. So now I know where to look And I want to now take this path here with me into my FastP document to replace this part here. That's the path, right? And Control V here now, so it will show up. And then the name of the file is, of course, must also be changed, right? But that was sort of given in the document, or I can actually copy that here as well now. This is the no, sorry, this was not the. This is a Illumina data file because it has this R1. So I copy this one by just dragging the mouse over it, and then I can go back here and paste it in like that. And then of course I know that the second file is almost the same. I can just copy this one and put it here. Take away that one first, and then I just paste in, and I change from R1 to R2 because Illumina data always come in file pairs like that, right? Now the output, where should I put the output? Well, I would like to keep the name. I think that is, if that's possible, I will always try to do that. So the out file is called the same as the in file. And isn't that confusing? You may say, okay, some people may think so. And you can actually call it whatever you like. So if you find this confusing, you can very well change the name. But I think this is a nice name. And then I would like to keep this first part of the name here. Or perhaps I should put this unpaired instead of the R1. Yeah, that's a good idea, right? So all the three files start in the same way, right? And the only thing that separates them is that this is R1 file, this is R2. Oh, no, I must remember to call this R2 file, and this is the unpaired file. Because after filtering, there will always be some reads who lose their mate, right? I think we have seen this before. So there will be an unpaired file with some reads, usually only a few reads in this third file though. But now I should have changed my script according to this at least. Input output file names. There is one more thing. I would like to actually output this to Scratch. This is the way it's specified now. It will just output to the working folder, wherever that is. And that's probably here in my assignment2 folder. Yeah, it's possible to do that. It's not an error if you do it, but actually now I would like the output to be on my Scratch disk, because that's how we usually do it. We output first to the Scratch disk and then we copy home whatever we want to keep. Actually, these files we want to keep, so it's not an error, as I said, to save it here directly. But just for the sake of the example, I want to send this to the Scratch. And actually I have, and then I can type like this $Scratch. Under the Scratch disk, I have made myself a folder called assignment2. And let me show you. I go out to the terminal again. And then I take LSA, but not here, but on Scratch. Like that. And I type part of the name and use my tab button. That's a very important trick. Always do that when you are in the terminal, or actually also in RStudio. If you are typing the name of a file or a name of a folder or a path, right? Try to type it sort of halfway and then use the tab button to fill in the rest. And it's not for speeding up the typing, it's more for checking that you have actually typed it correctly so far. Yeah, so here is my Scratch folder, and it contains a lot of subfolders, but you can see it has an assignment2 folder here. So if I now use the up arrow to repeat and I look into this assignment, and again I type half the name and I use the tab button, and it fills in until you can see there, because there is both assignment 2 and 3 here, so it doesn't know which one. Now I must type a 2 there, and then I can tab again, and then it's fine. So I list the content here is to empty, but this is the folder I want to output to now. And then I copy it in here, and I say that okay, this is where I want to put my filtered files, into this folder here, and keep that name, right? So now I just copy this and add it to the 3 output files here. Okay, if I go back to the module document now, I will see that we should actually use in the pre-processing here, we should use this apptainer containers. So we don't need to load, or we should not load this native FastPD which is installed on Orion, because we should use the apptainer solution right down here. And that means we have to add apptainer, execute, and then the name of a container. And if you go into the module 5 document, you will find that we did this actually in the end of at the end of this module 5 document. Yes, and here I am now in the module 5 document, just to look up that section. It's at in part 6 of that module document about containers, right? And here you can read a lot about use of containers, but if we scroll a little bit down here now, so we don't spend time on that right now, here is a suggested solution to use running FastP on the same input files that we just saw, but that we changed now, but using the apptainer container solution. And this was the one I was looking for. Here is how you now start FastP. You can't just type FastP anymore, you have to also open the container first. So this here I must copy now with me into my document here. So that was what I tried to start writing here, right? You can see that FastP was there already. So if I now replace this part with the one I copied here, I have apptainer, exec, and the name of the container, and FastP. And then the rest is as before. Except that also in this, there was some additional options we should add, right? These 3. So I do that as well. I copy them in here. Yeah. In the assignment document, it doesn't really say. It says that you should use at least these options. So we can actually leave this trimming as it is. I'm not sure it's really necessary or if it's actually a good idea, but I leave it as it is now. What you have to remember, and this is super important, when you add a new line to a command line like this, you have to end each line by this backslash. Otherwise, the command line will now end here. It will end here, and then you will get an error because you don't have this input. Because the command line doesn't, this indicates that the command line continues on the next line. But if there is no such thing, it doesn't continue. So then you will have an error. This is a new command then, because the previous one ended here, right? So now we have to remember to add this backslashes after each of these partial command line input. And here it ends now, right? So now it goes from all the way up here down here. That's the full command line. Okay, let me just try to run this now, because we don't, let me first save it. Save. And try to run this code. And how do we run it? Well, we go to the terminal, make sure I'm in this folder, so I just list the content. Is my FastP document? Yeah, here it is. My shell script is here. That's the same as I see here, and the same I have open here. Always verify that you are in this folder that you think you are, right? Where am I here? I am in this folder here. This is my username, home folder, and then assignment2. Yes. And then I can try to run this. And notice again how I tapped half the name, and then I use the tab button to fill in the rest. Because this is also, now I am sure that I'm in a folder where this file exists. Because otherwise the Unix system would not be able to fill in the rest of the name. So always make it a habit to use this tab button to fill in the rest of something you have started to type. SBatch. And then if I look at the queue now with my yeah, it's already done. But you can see here there was a log file here now. There was a log file, and if I look into my output now, I expect the output to be in this scratch folder, right? Scratch like that. Assignment2 like that, but there's nothing there. Then it's time to look into the log file. If things go wrong, then you look into the log file. Log file is a small text file, and you can, unless it is very big, you can click it open here in RStudio. And here we see a very typical error, right? Fatal. That sounds bad, right? While checking container could not open image, and that's an image is just another word for a file. It couldn't find any, of course, it couldn't find this file because there is no such file, right? If you look into that folder, there is no, this zip file is not there. This one, fastp:1. It's difficult to, we can actually look at the log file here as well. If the log file is big, you can inspect it here instead of in RStudio. And then you can see here it says could not open this file here, zip file, because there is no such file. Of course, it's not here. So what do? We need such a file, but I know that I have such a file already because I used it in module 5. So if I look one step up and down into my module 5 folder, or I could just type like this. I know it's under my home, right? There's a folder called module 5. Let me look into that. And there I can see this file. I have this, but I have it in the wrong folder, or in a different folder, I could say. So what do? I either specify where this folder, this file is found, or I copy it here. And I choose to do the last one now. I copy one step up into the module 5 folder, and then fast, and now I use this again. And it will only, notice now there are several files in that folder who start with fastp. So Unix doesn't know which one I'm referring to now. Which one do you want to copy? And now I have to type this colon, but a colon in the command line environment, you have to type \:. Otherwise it will not understand. And then tab. And then it can understand which file I'm referring to. It's this one. This one I want to copy here. And because the cp, the copy command, copies the file either to a new name, I can give the file a new name, or if I just specify the folder, it will keep the old name but end up in this folder. And single dot is always referring to this folder that I'm in now. So there I now copied this file, and now you can see I have a copy of it here as well. And this should now fix that error that I got here, because now this makes sense, right? Now this makes sense. If I did not want to copy, I could have added this here, right? To use the file where it was in the module 5 folder, or I can put this tilde here because it's under my home. This would also work, right? But I think that in general, I think it is usually a good idea to copy these containers into the folders where you use them. So if I go over here and refresh, you will see it here as well now. Have the container together with the shell script that uses them. Because imagine this is a bigger project, right? And you use this container. After the end of the project, you can put all this code into an archive. And if you want to go back some later day, you find all you need in that archive, both your own shell scripts and the containers they used. So that's why I think it's a good idea to keep the containers in many copies if necessary, just to have them together with the code that used them. Okay, this log file I can just delete now. I do it here. Because log files are only important for debugging, you could say. So now I have to remember to save this file here before I go back here and do the S-batching again. And then I can use the up arrow to just repeat the previous command. There it was. And now it's S-batching again. Let me see if it runs in the queue now. Yeah, here it is now. This is the one. It's been running for 8 seconds. And this looks promising. But it doesn't take very long time. So yeah, now it's 18 seconds. This is really promising. I mean, usually when thing crashes, it crashes immediately. Of course, not always, because sometimes the error is far down in the code, but very often it has something to do with how you start out with. It's either some input files you have mistyped or something like that. Very common. So let's see now. Yeah, a new log file appears. It's still empty, which is also a good thing. If the log file is empty, it means that there's nothing bad to report. Okay, some software will output a lot even if it works in the log file. So you shouldn't be worried if the log file is big. But I think that this one, yeah, it's still working. It takes some time, this. But now I would like to actually start looking into this Scratch folder. I mistype this word Scratch all the time. Assignment and then 2, right? And now we can see things starts to happen here. I get some output here now. It's not 100% finished perhaps yet, is it? No, sorry. SQ. Yeah, now it's finished. Now it's finished. Let me refresh here to see the log file. 1.4 kilobyte. I can click it open like this. Yeah, and if you go to the bottom and there is no error or something like that, that's a good thing, right? That's a very good thing. So this looks actually like it worked now, right? And I can list the content on that folder again. Yep. Here are my pre-processed reads now. And actually in this log file, you can find this information about how big was the file before filtering, both in number of reads and bases here, R2 before filtering, and the same files after filtering. So that was also something we asked about in this assignment. But now I have the code that works. And before I end here now, what I should do now is to copy this code here. I don't need the last part there. Copy this code, sorry, copy like that. to my markdown document and put it into this chunk. Now I just delete what was here from before and I put it in here, right? No, oops, sorry. Didn't I copy this? Control C, Control V. Yeah, there it was. This is my newest version now, right? And this is a shell script that actually works. Now I should do this for my sample B as well. And then you just go into the shell script and just change the file names, of course. That's the only thing you need to change here now. And run the same script again. But in the markdown script, I don't do that. I simply now have this one single script and I type under here, in order to pre-process sample B, I used the same script but changed, changed the names of input/output files, right? To the sample B variants. So don't put in your report two scripts who are almost the same, but with only difference being the name of the in and output, because that's a waste of space, right? We understand, everyone should now sort of understand that, okay, you can use the same script again, but by just changing the names here. And then S-batching, and you get a new set of output files, right? So please do that. Put some text each time, and this you will see over and over again, right? In the next part, there is the same thing again when you're doing this K-mer counting, and also with the when it comes to the assembly at the end, it's even worse because there you have 4 variants, right, of the Illumina data, both sample A and B, and raw data and pre-processed data. You use the same script over and over and over and over again, and you just have one copy of it in your report, and then you write with ordinary text how you use the same script again and again and again. Where did I modify things? You should write actually which variables here are modified. I didn't write that. I would say you should write that, so you demonstrate that you know where you do the changes. It's the R1 in, R2 in, and the R1 out, R2 out, unpaired out. These 5 shell variables you need to change the content of. Okay, then you could just knit away, and at least this part of the document should be done now, right? Without running any shell code, just showing it like this and explaining what it does and what you did in order to reuse it multiple times. Then you should be on your way to making these reports.